And so I will make these available to people later, and then let's hope everything works. All right, so this is large enough that people can see. So here's a couple of topics that I wrote that I thought might be fun to discuss. And so a lot of it is going to be games. I think games is a great way to get people involved. As much as possible, you want people to be hands-on. This is, I've been told, the 21st century. I'm just saying this because I talk to some people who don't seem to recognize the fact that we're in the 21st century and are trying to reproduce what was maybe good in the 1800s, but is not appropriate for a math curriculum in the era we are at now. So as much as possible, try to gather data with students, try to do some cases, build up some intuition, and get some patterns from that. So as much as possible, I want to try to emphasize stuff like that. There's a tremendous amount of videos and whatnot that I've made over the years. These are all available with slides. I will share all these slides with you so that if you want more details about anything, of course, obviously ask me, but I've tried to put these things online with slides to make it as easy as possible to implement. All right, so this is one of my favorite math riddles. Because I'm projecting from like a PowerPoint, it's going to give me spell check errors like that, but it's not worth switching to the PDF. All right, so this is the problem I asked you to think about. You have an army with 10 generals. One wants a security system such that any 3 of them can determine the code to launch, but no 2 of them can. It is possible that you can do this by using a quadratic polynomial. So how many of you are teaching quadratics? Okay, so at least a good number of you have been teaching something like this. One cannot give each general one of A, B, or C. So the password is going to be the triple, the A, B, C, the coefficients of the quadratic. So if you give me that triple, you can launch the missiles. And I want to give information to people in such a way that any 3 people can launch, but no 2 people can launch. And so the question is, how do I give out the information? Who gets what? Okay. So can somebody tell me why I can't just give somebody all 3 coefficients?
Because then one person can launch?
One person can launch. Okay, so yep, cannot give one person all 3. Can you give somebody 2 out of 3? Mary looks responsible, handpicked by Henry. We're going to give her 2.
If you give one person 1, then 2 people could launch.
So good. So if Mary has 2, so let's say if Mary has 2, which 2 should we give her? A and B, right? Make it as easy as possible. If Mary has A and B, does somebody have to know C? What would happen if nobody knew C?
No. Because if someone knows C, then Mary and that one person can launch.
Good, but that's what I'm saying. Somebody, the way we're dividing things up, somebody would have to know C, and then you would have a group of 2. So if Mary has C, A, B, no one can know C, or 2 could launch. Okay. So we can't give somebody all 3. We can't give somebody 2. Can we give just 1 to a person?
No. Well, yes, but then.
All right. So let's start off. Helen, what should we give you?
A.
Helen gets A. We'll go this way. Lisa? What should we give Lisa?
B.
B. Stephanie? And then no matter what I get, we're in trouble.
Can I ask a question?
Yes.
Do you know that you have A? Like, do I know that my? Do you know that you have A?
Yeah.
Yeah.
Do I know what I have?
So that's a good question. There are some security systems where you may not know what you know.
But in this case, you do.
In this case, you do, and even if not, even if Helen doesn't know what she has, this is not quantum mechanics. She has something.
So do you want it to be any 3 people or a specific?
Any 3 people can launch.
Because then that, like, how if there only be people who have A and B, 2 can be together.
Yeah.
Right. So if you give me an A, then Helen, Lisa, and I can't launch.
Yeah.
If you give me a B, Helen, Lisa, and I still can't launch. If you give me a C, Lisa, Stephanie, and I can't launch. So nothing works. So what we've seen is there's no way to do this if I'm giving people subsets of A, B, and C. So I have to give people information another way. Yes.
Go to roots.
So one
Depending
possibility.
on what type.
Sure. So, always good to try things. So we have, say, f of x is ax squared plus bx plus c. We can write it as a x minus r1, x minus r2. So we can factor it. So I do have two roots to give, and I do have the coefficient a. If you know the roots, you can expand out and get the polynomial.
Is that the same as the last case though, where like each of us have three roots? Like A root one and then
So,
two?
so here, there's three pieces of information, A, R1, and R2, and so we would have the same trouble.
Right.
But what if Helen, Lisa, and Stephanie get A, B, and C, and then I and Joe get R1 and R2? Can you start playing games like that and say, maybe if some of us know roots, two people who know roots can't do it. With my one root, could I do it with A and B? Well, the only thing we're missing is, could we try to figure this out? So A, B, and a root, is that enough to get C? Or can C be changed? So let's say, Helen gets A, Lisa gets B, Steve gets R1. Does this give C? So we would know ax squared plus bx plus c equals ax squared minus a r1 plus r2x plus a r1 r2. And so we know A, we know B, we know A, we know A, we know A, we know R1, we know R1. So we know B has to be minus A R1 plus R2, and we know C would have to be A R1 R2, and the only things we don't know is R2 and C.
But we can figure out, yeah, R2 from the
So we can get R2 from the first one,
B. Yeah.
and then now that we know R2, we can get C.
Yeah.
So this would actually not work. And so if I know the root and I talk to people who know A and B, that's enough to get the third piece of information. But this is what you want to have happen, is you want to have discussions, you want to have thoughts. How could we try to do this? Is there ways to control things? Has anybody ever plotted a parabola? And before you plot a parabola, what's the easier thing to plot? No, not parabola, an easier shape.
A line?
A line, right? How much information do I need to give you to plot a line? 2 points. So if I give you 2 points, that uniquely determines a line, right? And so I could give lots of people points. And any 2 people, if they get together, could plot the line. For parabola, how many points determine a parabola? 3. And so, maybe the parabola looks something like this. Actually, no, that would be a terrible parabola. Better to draw the parabola first and then put on the points.
Good idea.
And so if I give you 3 points on the parabola, can you figure out A, B, and C? Yeah, you would then have, let's say this is x1, y1, x2, y2, and so on and so on. So you would have maybe y1 equals ax1 squared plus bx1 plus c, y2 equals ax2 squared plus bx2 plus c, y3 equals ax3 squared plus bx3 plus c. If your students are familiar with matrices, you could write it as some matrix hitting ABC is y1, y2, y3. It would be x1 squared, x1, 1, x2 squared, x2, 1, x3 squared, x3, 1. You have 3 equations, 3 unknowns. You can solve it. And what's great is 2 people will never be enough to determine it. You can also try to modify the problem and go in different directions. Does everyone agree that Mary is the most important person in this room? Without a doubt. She controls the coffee, and I actually forgot to bring the afternoon snack, so it's really bad today. So maybe we give Mary more power. Maybe we give Mary 2 points on the parabola. So then 1 other person would be enough with Mary to launch. If we wanted to have 5 votes needed, instead of using a polynomial of degree 2, what should we use to get 5 people?
Degree 4.
Degree 4. And so what you could do is maybe the president gets 3 points. Maybe the vice president gets 2. You could have weighted systems like this. I was in a department where 2 people were married. I have served on committees with my wife. Should we be considered independent? On some committees, we actually cancel each other out. And so, sometimes we would vote together, sometimes we would vote for opposite things. So it's not necessarily bad that we're both on the committee because we would provide different perspectives. But you might say, wait a minute, we'll give each one of you 2 votes because you're both important, but one of your points will be the same for the 2 of you. So that the 2 of you don't really have 4 points between the 2 of you. You only have 3 points between the 2 of you. You can play lots of games like this. There was the beautiful question of, do you know what you know? And so we can definitely do a lot on cryptography later. There's a lot of great math behind that, but just here's 2 different systems for encrypting information. The first password is a number n, which is the product of 2 primes, p and q. So p, q are prime, and they're, let's say, of size 10 to the 200. So they're large prime numbers. Okay, and I make public and so the password is P or Q. So there are 2 passwords. Does anybody have a sense of how big 10 to the 200 is? Put things in perspective. There's less than 10 to the 100 objects in the universe. So if every object in a universe was a universe, that's less than 10 to the 200. So if you wanted to just imagine a supercomputer running since the dawn of time, it would not be enough to check on the order of how much we would need for something like this. So another way of saying this is, if you had a universe of universes, you and I are both thinking of the exact same particle. That's the level of likelihood. So whenever possible, when you have these absurd numbers, you want to try to find a way to relate it to the students in such a way that it's meaningful. Has anybody read Hail Mary, the new book?
Yeah.
Okay, I'm looking forward to seeing the movie with friends. I have a degree in physics, and I was sweating a little bit as I was reading this book, trying to do the calculations that he was doing so effortlessly to figure out what the hell was going on. But it was a great book in terms of putting things in perspective. The reason I'm saying this is I have a physics degree. I was reading a book that was talking about how energetic radiation was, and I had absolutely no idea what those numbers mean because I don't work with these concepts that often. But the book, they did something wonderful. It said, imagine you go to the dentist and they're putting on the lead apron. If the apron ran from the sun to Pluto, it would not be enough to stop the radiation. It's like, okay, I've got a sense of how energetic this radiation is now. It's put it into a perspective that I can understand. 10 to the 200 is huge. But some of you may be concerned that maybe that's not quite huge enough. So here's the other. For those of you who are really paranoid, choose a random 5,000 digit number, X. And the password is X. So which do you think is more secure? I choose a number that's basically the product of two primes. Each prime has about 200 digits. Or I choose a number X, which is of size 10 to the 5,000. Here you have two things that work, whereas in the second you only have one thing that works. Which do you think is more secure? Which do you think is going to be harder to crack? It's okay if you're wrong, just the way it should be guiding you to saying one of them clearly looks like it's more secure.
Wait, so you have two things, each one's 200 digits.
So I take two prime numbers,
Yeah.
each one is about 200 digits, I multiply them together, and I tell you what the product is.
Okay.
And then all you have to do is give me one of the factors. You could basically pretend not to know any number theory and not even try to factor, just try to guess all 200-digit numbers. Or I have a 5,000 random digit number. And you have to give me the 5,000 random digit number correctly. Or you have to give me one of two 200-digit numbers. So I'll put you on the hot seat because you're the one who inspired this.
I feel like prime numbers are easier to predict than a random $5,000 digit number. And especially when you get to that big of a number, it's fewer. And
there's far fewer things, 10 to the 5,000. Right, the only two factors of n, but you can even forget about the fact that n factors is a product of two primes. You can just keep trying all 200-digit primes. Doesn't it seem like there's a lot fewer things to try that have 200 digits than 5,000 digits? Does it seem like the first thing is going to be far more secure? I'm sorry, far less secure than the second. The second is going to be much harder. The second one is very bad. So in the first one, it's bad, really, really bad. How does the computer know if you have the correct password for the first one? You give it, here's my proposal. I believe this is the password. All the computer has to do is divide n by your number. Does the computer need to know the password in the first case? No, I'll know it when I hear it. None can pass who don't know the password. What's the password? I don't know. I'm not allowed to pass myself. I just guard the room. I won't let anybody in who doesn't have the proper password. What about the second one? Does the computer need to know the password? Yeah. You have the ability to capture some of the computer, open it up, and it's got to be stored somewhere on it. A lot of times when people are creating certain encryptions, they destroy the computers on which things were made. But if you have something like this, the computer has to have hardwired somewhere.
How does the computer not have to know the number?
For this one? Because all it has to do is it has to divide. Yeah. So in the first case,
yeah, since it's the
so if you think
so it's just like you get an integer result.
Right. If you think X is the password, if n divided by X is an integer, you go in.
So it just stores that like rule, not the.
Okay, good. Looks like we've been able to fix the technical issues. Wonderful. Okay. So this was the general code. To me, if you're teaching algebra, this is a great way to talk to people about how might you use things like a quadratic, in more than just, the trajectory of a baseball, a cannonball, football, something like that, water fountain. You see a lot of these parabolas all the time. Here's another way of looking at it. And then what's great is to try to figure out, can you come up with your own encryption system? Could you use a qubit? Could you use a quarter? Could you try to use roots? If you know some information, no one ever asked this question before. What if somebody knows the root and somebody else knows some of the coefficients? Is there a way to split things up so that you can control who knows what? Before going into games, I wanted to talk about hedging bets because this is a good topic for this time of year. So I teach probability, and one of the first things I do is I establish that I am a balanced, fair professor. Even though I'm a Patriots fan, I will talk about times when the Patriots have not done well. And so I will talk about the spectacular season where they almost went undefeated. And so a friend of one of my favorite students told me that he had a friend who put $500 on the Patriots to go undefeated and win the Super Bowl. And this was the season they were undefeated in the regular and only lost in the Super Bowl by a very small amount. And it was 1,000-to-1 odds. So if he wins, he gets $500,000. In the third quarter, with the Patriots up, he is contacted and said, "We'd like to buy the bet back from you right now. We'll give you $175,000 right now." And his response was 2 words: "Go Pats!" And he ended up with nothing. What was his mistake? What did he do wrong?
Got greedy.
What should he have done?
Should have calculated the expected value of that bet and realized that $175,000 is way more.
Well, but if the Patriots are going to win, if the Patriots have a good chance of winning, he's throwing away over $300,000. But there's something. He would definitely have, but there's something he could have done.
Have you negotiated with them?
So one possibility is he could try to negotiate. He says, "I'll sell it to you for $350." If you've ever seen, what's the game show with all the cases? Good cases? Deal or No Deal. Right. So frequently the negotiation in Deal or No Deal is we don't want people to just accept the deal and walk away. We want drama. And so they will often make things. A lot of times it depends on your personal financial situation. If you are facing, say, huge medical expenses for a family member, the $175,000 might be life-changing. You might not be able to afford. But there's something simple he could have done. Before the game began, he's got a bet on the Patriots. What could he have done?
Oh, bet against.
Bet against.
Oh,
He could have put a bet
Yeah.
on Seattle, or this year when the Patriots were, I mean, big bet on the Giants. This year when the Patriots were playing Seattle, the students in my Math of Lego class told me that they had a friend who had a free bet because he had joined one of these online sites, and he had a free bet on the Patriots to win the Super Bowl, and if it wins, he gets $2,000. And I begged them, please convince your friend to put a secondary bet on Seattle. And we did the calculation to try to figure out how much. So how many of you are teaching equations of lines? So this is a great way to try to talk about how would we do something like this? How would we do a simple mathematical model to try to figure out? The other thing is there's a huge difference between pure math and applied math. You also have to include the psychology and the personal situations. We're going to have some fun games that really change depending on how you model people. And having everybody assumed to be a perfectly rational mathematician does not always work to try to model the real world. I will assume everybody here would like to get $500,000. If it will not make any difference in your life, please talk to me after class. Would you rather get $500,000 or $100,000? This is basically who's awake right now. You'd rather get 500,000 than 100,000?
Yeah.
Great. Which would you rather get? 500,000 or a million? Right. These are not hard questions. How much more valuable is the $1 million to the 500,000? Is it double? You're going to lose a lot on taxes. Depends what you do with it. But the marginal utility of the second 500,000 is not going to be as much as the first 500,000. The first 500,000 is going to have a much greater impact on your life than the second 500,000. Which would you rather have? $400,000 guaranteed, or a 50% chance of $1 million and a 50% chance of nothing? Almost everybody's going to say 400,000 guaranteed. The expected value is greater if I give you $1 million half the time and 0 half the time. It's $100,000 more. If you could play this game 1,000 times, then it's no question. Clearly, I'll take. But if you can only play it once, it's actually not a bad idea to take the lower expected value because it's less risky. And so you have to decide when you're doing stuff like this, how much does the risk matter? The $2,000 is not going to be enough to change my student's life. So he might be willing to do all in for the Patriots and not put a secondary bet on Seattle. For the $500,000, this is life-changing, especially if you're a student. It's worth putting down a second bet. So I thought it might be fun to just do the calculation of how would you figure out how to make a bet in a situation like this? Whether or not you can get this by the school boards and the chairs of your departments to have a conversation like this, you can say, it's come to my attention that some people do the following.
Wait, Steve, I'm an English
Yeah.
teacher, so excuse me, but what does the second bet exactly get him that he wouldn't have had if he didn't have the second bet?
So he could put a bet on, so the Patriots are playing Seattle.
Yeah.
And he has a bet that the Patriots will win, and if the Patriots wins, he gets $2,000.
Right.
He can now put a second bet on Seattle to win. Now, if he has two bets, so let's say,
So it's not in the first, it's not in the $500,000.
well, in the 500,000, you could put a bet on the Giants to win. You could put a bet on the Patriots to win and a bet on the Patriots to lose.
Are you saying the same amount of bet?
We have to figure out how much to bet. So it doesn't have to be the same amount. And the point is, at the beginning of the year, if you want to bet on every team to win the Super Bowl, they'll let you, but the odds are against you. The phrase is somebody has to pay for Mr. and Mrs. Smith's suits. And it's not Vegas. It's the people who are putting the bets. So it's set up so you always have the expected value of losing just a little bit. But deep in the season, if one of your bets is still active and live, you might be in the situation where now there's only 2 teams left. I don't have to be dealing with 32 teams. I can now put a secondary bet on the other team. So let's say we bet $1,000 on Pats to win and pays. So I was going to do this with specific numbers. You could, of course, do this more generally, but I think it's nice to just have specific numbers. Pays, say, 5,000 if win, and then you get nothing if you lose. Okay. Could bet on Pats to lose as a second bet. Let's say Pats win with probability P, and say if Pats lose, for every $1 you bet, you get maybe $0.25. Okay. So because the Patriots are favored to win, oh, wait a minute, this might not. Oh, sorry, because the Patriots are favored to lose, if you're betting on the Patriots to lose, you shouldn't be getting as much. And so because the Patriots are favored to lose, if you bet $1,000 on the Pats, we're going to give you $5,000. We don't really think Patriots are going to win. We're going to incentivize you to bet on the Patriots. If you want to take the team that we think is going to win, we're not going to give you the same rate of return. So the question is, how much should we bet on the Patriots to lose? And like many things in life, people can actually agree on the answer, but disagree which answer is the one that they should go for because they disagree on which things to maximize. Are you trying to maximize your expected return, or are you trying to maximize your guaranteed return? So if you want to try to maximize your expected return, I need to know the probability the Patriots win. The lower the probabilities the Patriots will win, the more likely I want to put down a bet on the Patriots to lose. If the Patriots' probability of winning is 100%, do I want to put down a secondary bet? No. If the Patriots are going to win, it's stupid to bet against them. You always start with extreme cases. If you can't understand the extreme cases, you have no chance in general. So if the Patriots are going to absolutely, definitely win, it would be foolish to bet against them. If the Patriots' chance of winning is 99.9999, then almost surely the Patriots will win. I would probably want to put very little. So one possibility is to try to maximize the expected return. The other is to maximize the guaranteed minimum. Yes.
Are you trying to get the same dollar amount, or just we're looking at?
Well, it's two questions. One is, what's the average amount I expect to earn? And I want to make that average amount as large as possible. Or the other is I want to guarantee myself the largest minimum so that no matter who wins, I'm going to guarantee that I get maybe at least $800 or whatever.
Okay, because I wasn't sure if we were looking at like 5,000, and we're like, okay, we're looking.
Well, so
to make
the first bet, I've already placed the first bet. That's locked in. I've bet $1,000.
Okay.
If it wins, I get 5,000. If it doesn't, I have nothing. So a lot of people have trouble with this concept that once something has been done, it's done. I can't change it. It doesn't matter if I would want to do a different bet there. That bet is already done. I don't have to take into account how much this bet cost me. That's already been factored in. All I have to take into account now is I can put down X dollars on the Patriots to lose. And so I can try to calculate how much do I make if I bet X dollars on Pats to lose. So is the amount I make going to be a function of whether or not the Patriots win or lose? Sure. I'm gonna place a bet of X dollars on the Patriots to lose. And I want to know, how much do I gain at the end of the game? Is the amount I gain going to depend on who wins the game? Yeah. Right? So if the Pats win, I make $5,000 and I lost X dollars for the bet. So I have 5,000 minus X. And if the Pats lose, I make 0.25X. Yes.
Would it be 0.25x minus 1,000 though, because you already paid 1,000 for.
No,
We're not taking it into consideration.
Well, no, that's
So you're
already.
just at a net loss.
Well, but I could put the minus 1,000 in both of them
Yeah.
because I've already.
But so your goal isn't to recover what you already paid, like it's just a gone.
It's just a gone. So now I just want to make sure I've done things correctly.
So 0.25x or 1.2?
Yeah, that's what I'm wondering is, it's got to be, I think, 1.25x because you got to recover the amount you bet. Otherwise, no matter what, you would never do it. So in fact, I was going to write it as this plus X back. And so I want to do it like this, as 1.25x. So you get your bet back and you get $1 and you get 25 cents back. Otherwise, no one would ever take the bet.
That's right.
So, yep. So here is my function. F of x is 5,000 minus x if the Pats win, 1.25x if the Pats lose. Whenever you look at math, you always want to ask which things matter. There is one number here, or two numbers here that haven't come into play. One is $1,000. It's gone. So we don't need to factor it. I could subtract 1,000 if I wanted from those, but it doesn't matter. $1,000 has already been spent. But there's one other thing that has been mentioned here that has not shown up in F. The probability. This probability P does not play a role. Now, if I want to calculate on average how much do I want, then I would weigh each one of these. I would weigh the top by P and the bottom by 1 minus P, and I could then calculate my average. And so if you want to then try to figure out on average, how much do you make? It depends greatly on how likely the Patriots are to win. If I want to calculate my minimum, what I will always assume is the worst thing happens for me. And so whichever one of these two is smaller is how much I get. So if I do this properly, I should be able to copy this to the next page. Yes. So what I can do is, so worst case is you get the minimum of the two. So what I can do is I can plot things. And so here's X, and here is the money that I get. So if X is 0, what would I have? Or 0. So if X is 0, how much money would I get? Worst case. 0. Worst case, it's 0, right? So how would you plot the minimum of two things like this? I would just plot it as two lines. And so the first line, y equals 1.25x. So it would be a little bit steep like this. So this is y equals 1.25x. And what's the next one? The next one is 5,000 minus x. So it start at 5,000 and then come down like this. So this would be y equals 5,000 minus x. And so now we'll do like the golden line. And so this point of intersection will be my guaranteed minimum. So I just have to figure out where do these two lines intersect, and that will tell me how much to bet. That's the special bet. So I want 5,000 minus x equal 1.25x. So 5,000 equals 2.25x. So that's 2 1/4. Yes. So this is 9/4. So x equals 20,000 over 9. And that would tell you exactly how much you should bet. And you can change the amounts. You can change how much you get for the Patriots losing. And you can see how that impacts here. But all we're doing is we're just doing equations of lines. And we're just seeing where do they intersect. If you want, it's a nice exercise. Try to do the expected value case to figure out on average how much would you make, and that's going to depend on P. And now if you're making a bet like that, it really depends on how much knowledge do you have on the likelihood of the Patriots winning or losing. But what we're doing here, if we're only concerned with a guaranteed minimum, we can figure out what that is. And now that we know that X is 20,000 over 9, we can then actually plug that in here and see how much we're guaranteed to make. We're not talking about fortunes here. So it wouldn't be surprising if somebody says, you know what, I'm willing to just risk 5,000 or nothing. But if we're talking about something on the order of 500,000, the friend of my friend was an absolute moron. I mean, there's no kind way of saying this. Not to put down a secondary bet against the Patriots. As an aside, the way a lot of betting works is Vegas chooses the line not on what they think is going to happen, but they want to try to maximize their profit, which means they want equal amounts going both ways. So sometimes professional gamblers have people whose job it is to place bets for them anonymously. And sometimes the purpose of your bet is to lose. But by putting a lot of money on, say, Team A, it makes the line now more favorable. And then you can now put a bigger bet by somebody else on Team B, and you've moved the line so you now have a better chance of winning or covering or whatnot. So you've got to be very careful. There's a lot of really interesting stuff to look at. All right, so I want to do one last thing before we take our first break. It's much easier to speak than to listen. And so I just want to give you a sense of a couple of things. How many of you have seen the Fibonacci numbers before? Okay. Is there anybody here who has not seen the Fibonacci's? Okay. All right. We will see them later then. Okay, let's pause now and we'll do an activity. So I'm going to hit pause. Actually, I'll stop the recording.